What's going on, Algebra Bros? It's Mr. C here, and as promised, I would circle back around to complete a video on this example where we're given the general form of the equation for a circle, and we want to identify the center and the radius. We will then proceed to graph the circle. Alright, so I'm going to give you a little spoiler here. In order to find the center and radius, we're going to rewrite this equation in standard form. Once we have it in standard form, it's really quick and easy to figure out what h and k are, as well as the radius. So here's how you want to start this out. Let's first take this 18 over to the other side. And I'm going to rearrange some of these terms. In particular, I'm going to write x squared minus 6x, and I'm going to leave a little bit of a gap there before I put the positive y squared plus 10y, and another space to follow that, in which case I'll write the equals negative 18 behind it. The reason for these spaces is due to the fact that we're going to complete the square. And we'll actually do a couple rounds of it. We're going to complete the square with the terms involving x, as well as complete the square with the terms involving y. Now the key numbers that are going to be helpful for us are the coefficients of the linear terms. In other words, the negative 6 that's in front of x and the 10 that's in front of y. What we're going to do with each of those numbers is split them in half. So I'll take negative 6 over 2 and then square the result. And this is going to be added to x squared minus 6x. Now the negative 6 over 2 squared is a new number in this equation, so to keep it balanced, or to keep this equation an equation still, we're going to have to add negative 6 over 2 quantity squared to the right hand side. I'll also add half of 10 quantity squared to each side. Now we'll simplify. Negative 6 over 2 is negative 9, but when you square it, you get positive 9. Plus y squared plus 10y, and this is going to be 5 squared, in other words, positive 25. And that's what those expressions simplify to on the right hand side as well, as you would expect. So on the right, it's going to be negative 18 plus 9 plus 25, which, combining all three of those numbers together, gives us 16. Now the reason for adding half of these coefficients squared is because we get trinomials that factor as perfect squares. For instance, x squared minus 6x plus 9, if we just focus on that expression all on its own, you could factor that as x minus 3 times x minus 3, which can be written using exponential notation, x minus 3 quantity squared. In a similar vein, y squared plus 10y plus 25 can be rewritten in the factored form y plus 5 times y plus 5, in which case, using exponential notation, can be condensed into y plus 5 quantity squared. And just like that, we have put the equation for our circle in standard form. Okay, well, let's discuss the center as well as radius. Okay, the center is generically given by h comma k. And the easiest way to find these two numbers is to think opposite. In particular, Let's look at the first set of parentheses. The number that we have in here can be thought of as like a -3, and the opposite of -3 is +3. So that would give us our value of h. Inside the second set of parentheses, we have a +5, and the opposite of +5 is -5, which would give us our value of k. As for the radius, we want to take a look at the number on the right-hand side, the 16. When this number does not have a power of 2 on it, it means that something has already been squared to achieve its value. So in other words, this 16 is the result of simplification of r squared with a particular value of r. So the easiest way to get the radius, if there's no if there's no exponent of 2 on this number, is just to square root it. So it's going to be the square root of 16, giving us a radius of 4. And that's how we can find the center and radius of the circle upon transforming the equation from general form to standard form. Now let's graph it. Graphing the circle really just boils down to 3 steps. Number 1, you plot the center. So I'll say plot h comma k. Our center is at 3, -5, so I'm going to start at the origin, go 3 spaces right, and down 5 spaces. And then the second thing to do is to use the radius, or in other words, use r, to generate 4 points on the circle. Now the points that I go after are the points that are r units above the center, r units below, r units to the left, and r units to the right. You see, the center is not actually on the circle itself, but it obviously helps establish it. But you need to use it in conjunction with the radius. And so every point on this circle, this one in particular, is going to be 4 units away from the center. So with that in mind, we start at the center, and we're going to go up by 4 units. That takes us to the ordered pair 3, -1. We'll go back to the center and go down 4 units, like a G unit. That gives us the ordered pair 3, -9. Let's go back to the center and go left 4 spaces. That gives us the ordered pair -1, -5. And go back to the center and go right 4 spaces. That's going to give us 7, -5. And the third and final step is to connect the points from step 2. I'm going to put it this way, in a circular fashion. How do you like that? Dabbing emoji for that one. Alright, this is a no judgment zone, by the way. Just do your best to connect all 4 points in a circle as best as you can. And let me just re-emphasize the points we got using the radius. And voila, there you have it. Okay, I'm going to follow this video up with instructions on how to, or a demonstration I should say, a demonstration on how to locate the intercepts of the graph of the circle. Alright, so stay tuned. In the meantime, let me know if you have any questions about this solution video. If not, then I will catch you in the next video, and thanks for watching.